The quantity of anesthetic vapor can be measured either by its absolute pressure in millimeters of mercury or kilopascals, or as a volume percent, which represents the amount of vapor in relation to the total gas mixture. The pressure exerted by the vapor can be explained by Dalton's law of partial pressure, which states that, in a mixture of gases, each gas exerts pressure independently of the others, and the total pressure is the sum of the partial pressures of all the individual gases. Let's say a patient is breathing a gas mixture that contains 49% oxygen and 49% nitrous oxide with 2% of an anesthetic agent like sevoflurane. With the total pressure of the gas mixture at sea level of 760 mm of mercury, we can calculate the partial pressures of each component as follows. So the total pressure of 760 mm of mercury is the sum of the partial pressures of all these gases. These concentrations are determined by gas analyzer in the anesthesia circuit and can also be ascertained from vaporizer dial. Now, why is the partial pressure important? The partial pressure of the anesthetic agent determines its physiological effect, as the agent's partial pressure drives its absorption into the bloodstream and tissues. And when we adjust the concentration on the vaporizer dial setting, we are indirectly adjusting the partial pressure of the anesthetic agent relative to the oxygen and other gases. Volume percent expresses the relative ratio or proportion of gas molecules in a mixture. The volume percent is a relative measure and doesn't change with pressure or temperature under normal conditions. For instance, if a gas mixture contains 2% sevoflurane, this means that 2% of the gas molecules in the mixture are sevoflurane molecules. As mentioned earlier, the concentration can be determined by setting on the vaporizer dial and also from the partial pressure measured using a gas analyzer. Expression of quantity of anesthetic gas in percentage is important because the vaporizer dial is set to deliver gas in proportion to oxygen, air, or nitrous oxide. Anesthesiologists often need to adjust the concentration of anesthetic gases delivered to the patient. Percentages are straightforward for setting and adjusting the concentrations on vaporizers. The minimum alveolar concentration that determines anesthetic potency is also expressed in volume percent. Expressing Mach in percent ensures that the value remains consistent regardless of changes in atmospheric pressure, making it a reliable measure under different conditions. So it makes sense that anesthetics are delivered in percent, though the action of it depends on the partial pressure.